Hello YouTube, back again. One of my videos got a lot of attention lately about testing the capacity of hybrid battery cells, specifically the Toyota side. Even though these cells are in anything from a Chevy Tahoe to a Toyota Prius, these nickel metal hydride cells, there's a lot of confusion about where people should be charging them, what's going to cause a check engine light, what's a good battery and what's a bad battery, what's a battery block, how to balance them. I've heard so many questions over the last few months. I'm going to make you guys a video tonight to show you how I test the capacity of these cells and what I would install in a vehicle again, and also what's not going to cause a check engine light. I'm a German and import specialist. I've been trained at the dealership at 3 different brands. I started my career off as a Toyota technician, and they taught me how to be a high voltage specialist. I then went to Volkswagen to work on EVs, and then finally ended up at Tesla, where I pretty much started my own career working on rebuilding batteries. I'm now going to go over the battery voltages and what you should charge the battery to and discharge the battery to. Each battery has 6 cells with 1.36 volts in each cell, which will give you 8.2 volts fully charged. A fully discharged battery will have 1 volt in each cell, which will give you 6 volts fully depleted, which will give you a nominal voltage of 7.2 volts. That's why they call it a 7.2 volt battery. This ToolkitRC M8S charger is an amazing little charger. It could charge anything from a LiPo battery to a nickel metal hydride Prius battery, which is really cool, I think. What I'm powering it with is a ToolkitRC adjustable power supply. It's a P200 ToolkitRC. Pretty amazing little power supply too, I gotta say. Let's charge the battery. Take your positive lead and hook it to your positive terminal. Take your negative lead and hook it to the negative terminal. What's cool about this charger is the adjustable power supply has a over circuit protection, and it also has a diode built in for charging batteries. It's one of the only power supplies I've ever seen where you can actually charge a battery from. Where this power supply here, I couldn't charge a battery because it doesn't have those features. This little RC charger is awesome. I want you to adjust the voltage to 8.2 volts and the amperage to 2 amps. Do not charge the battery more than 2 amps because the battery will swell outside of the pack and could cause the battery to explode, or can also cause the battery to fail. After adjusting the amperage and voltage to the correct settings, start the charger, and as you see, the battery is now getting voltage and amperage. When the battery is fully charged, it will read 8.2 volts here, and it will read 0 amps going in. Thermal runaway with a Prius battery here today. Just check that out. With the battery being fully charged now and the amperage reading 0.0, we know that the battery cell is fully charged. Remove the battery leads and come over to the battery and let it rest for anywhere between 20 minutes and 45 minutes. When the battery's got to a resting voltage, the resting voltage should be between 7.8 volts and 8.2 volts. That means that it's worth capacity testing. Anything that's less than 7.8 volts is not even worth testing. I'm now going to go over what a battery block is. A battery block is 2 individual cells put together to make a full voltage of 16.4 volts at a full charge. And a fully depleted battery block would be 12 volts, which gives you a nominal voltage of this battery block of 14.4 volts. On a scan tool, the data that I'm seeing, the working voltages are from 16.4 volts to 13.8 volts. Anything that goes higher or lower will cause a check engine light for a bad battery pack. Now that we have a good idea what a fully charged battery should be and a fully depleted battery should be, it's time to perform a capacity test. I'm using a little bit thicker wire to perform a capacity test with some basic ring terminals here that are just tightened down with an 8mm ratchet or a wrench. With the battery being fully charged 2 hours ago, it's had enough time to rest to test the resting voltage to see if it's between 7.8 volts and 8.2. When discharging a battery, you're going to want to use thicker wire. I just use some basic ring terminals and tighten down to 8mm bolts. You can use clamps too, but I just think that this is a better connection. Plug the battery into the hobby charger and go to the charging section of the hobby charger. Here in the settings, the battery type that you're going to want to use under the setting is nickel metal hydride. You're going to want to use a 6-cell configuration and a discharge current of 1 amp. Now we're going to start the capacity test. Make sure again that all your settings are correct. Do not discharge more than 1 amp at a time. You could. I think that you get a better reading myself personally. And in the instructions here is saying that it's going to discharge this all the way down to a 0.5 volt. You have to pay attention to this. We know that a fully charged battery is 8.2 volts and a fully depleted battery is 6 volts. And we also know that the battery is sitting for almost 2 hours, and we know the input voltage here has to be between 7.8 volts and 8.2. Let's check it out and see where it's at. Let's push OK. As we see, the battery is at 8.10 volts, or 8.1. So it falls into play under load at a resting voltage here. With the capacity test now running, you can hear it. It's going to take about 6 hours to get this all the way to between 6 and 6.5 amp hours at 1 amp. You could discharge it faster, but like I said, I think you get a better reading personally myself, and a more accurate reading at a 1 amp discharge. When rebuilding battery cells, capacity is the #1 factor. You don't want to replace any battery or rebuild any battery that has a bad cell in it. It takes a lot of work to disassemble a battery pack and put it back in the car and retake it apart again if you have one battery that's bad. This capacity test, even when you buy cells from online, no matter if it's from eBay, Amazon, it doesn't matter where you buy it. Make sure that you perform a capacity test. 60% of the time that I buy batteries on eBay, they usually end up being a bad battery. 40% of it ends up being a decently good battery. When buying batteries online, you have to be very careful. You have to look out for the words remanufactured or rebuilt. That's somebody that's lying to you right off the bat. There is no remanufactured, rebuilt batteries anywhere on the market. There's used batteries, and that's what that remanufactured or rebuilt means. It's a used battery. I have a link in the description where you can buy new batteries. There's only a few people out there that have drop-in batteries, and it's an upgrade from this nickel metal hydride to a lithium battery, which is really good. When I rebuild batteries, I use them myself, and I provide the customer with both options. Both options are correct. You can have a rebuilt battery with used batteries, and you can have a new battery. A lot of people don't discuss with their customers that there is nothing that is rebuilt. It's either going to be used battery that's rebuilt with used batteries, or it's going to be a new battery. I don't like how people word things online like that, or especially when you're buying new. You think you're going to buy a new cell, or you got a remanufactured cell, and all it is a capacity tested cell like this. There's nothing that's renewed or anything about it. There is no way to renew a battery. When this battery capacity is lost, it's lost forever. There's no way to regain it.
Dave, you're actually going to regen that like that? No way. Are you really? Gio, what's going on over here, man? That's what I'm talking about, man. Fully charged, man. That's how you charge it up. Tow it. You gotta tow it. Get the energy going, you know? You're regenning?
This capacity test just finished. After about 6 hours, the battery here contains about 5.59 amp hours, which is about 5.6 amp hours almost. Which, anything under 5.5 amp hours will cause a check engine light. This battery, if installed, wouldn't cause a check engine light, but in a few months of use would, because it's so close to the minimum between 6.5 and 5.5. Do not install this battery. With the first cell capacity test being done, we're going to mark the cell 5.59 amp hours, and we're going to disconnect this cable and we're going to move it to this battery and start the next test. It's time to start capacity cell test number 2 now. I switched the wires from this cell to this cell, and I've marked it 5.59 amp hours, so we know what the capacity of this is. As before, I want you to hook this battery to the hobby charger and go to the charger section and make sure that all the settings are as they were before. Go to the discharge section and start discharging this battery and finding what the capacity of this battery is. And as you see, we're between the 7.8 and the 8.2 volts, so we know that this battery cell is worth testing and finding out where it's at. Since this battery is worth testing, I'll see you in about 6 hours here. We're at 6.17 amp hours, which is a very good battery. I would install this battery into the battery pack without having any worries. This battery could last multiple years. Now that we know what a good battery is, and also a battery that's still good, but it's at the end of its life cycle, and is also going to cause a check engine light here soon, we're going to move on to what a bad battery looks like. And I'm going to leave the video running to show you, because it doesn't take 6 hours. These batteries took about 6 hours each to both deplete. The other one's going to take roughly about an hour to deplete. And I'm going to show you how the difference is on live video, what the voltages do differently, and what you should be looking for. I finished charging this battery 20 minutes ago, so it's time to do a capacity test now. As you see, it's holding 8.18 volts after 20 minutes. And that's in spec here. Let's do a capacity test. Go to the charger section again, just like the rest of them. The same settings. And go to discharge. Watch what happens to the difference between these two cells and this one when I put the discharge on. As you see how fast it's already dropping? None of the other batteries acted like this so far. That's only with 1 amp on it. I'm going to leave the video running here to show you what happens with this battery. See how fast the voltage is dropping in this battery? There's a huge difference between these two batteries and this one. The voltage is dropping immediately. It's not within 5 minutes of the battery. It's went from 8.2 all the way down to 7.87, which is a drastic drop. That's what you want to look for when you see a bad cell. If it's not holding its voltage like that, it doesn't even have any 100 milliamps yet after 5 minutes, it's a bad battery. You want to look for a battery that has at least 500 milliamps by this time, at least. And let the video run. This battery should be fully depleted within 30 minutes. Watch the voltage now. Doesn't even hold half an amp hour in this battery. Pretty crazy. And there she goes. There's a half amp hour capacity in this battery. Do you see the difference between the three batteries here? You have one that's really good, one that's on its way out, and as you see, this is definitely a bad cell, only registering at half an amp hour. Make sure to never discharge these batteries below 6 volts. It could damage the batteries. These batteries here are going to be recycled. Now that we know how to capacity test a cell, we know how to charge a cell, and we also know what a good cell is, a bad cell is, and what a cell is on its way out, I'm going to charge all three of these before I recycle them, and I'm going to show you how to balance a battery. Let's balance these batteries now. Balancing batteries are necessary. It's because battery cells drift apart in their state of charge over time. When charging batteries, one cell might become overcharged, while the other cell might be undercharged. This can happen due to inconsistencies during manufacturing, self-discharging rates, and a variance of internal resistance between the cells. We now got to make sure that all the voltages of the cells are at 8.2 volts. A little easier to have clamps when you do this. And as you see, they're all in 8.2 range. Any difference in charge level between individual battery cells will cause current to flow from the higher voltage battery to the lower voltage battery rapidly and uncontrollably, unless the battery voltages are similar. When I worked at the Toyota dealership 15 years ago, this is how I learned how to balance the batteries. We would make sure that all the batteries were in parallel, where positive and positive and positive were all facing the same way. That means that if you had all your cells, make sure that they're all positive in one direction, in one direction negative in the back. Make sure there's no cells that are not facing the same way. All positive on one side, all negative on the other side. I then want you to take bus bars. You're going to need an extra set of bus bars when you buy them. And I want you to attach the bus bars in parallel to make the one circuit. make sure that you fully charge each battery to 8.2 volts. These nuts are 8 millimeters. You can use an 8 millimeter socket or an 8 millimeter wrench. And you just want to tighten down snug. You don't have to wear high voltage gloves because the voltage is lower than 48 volts and it's safe to handle with your hands. Flip the battery pack around. And the same thing on this side. You're going to want to take the bus bars and attach to make a parallel circuit. Now that the bus bars are attached, snug this side down also. I want you to leave the battery like this for 6 to 12 hours. Well, it's been 6.5 hours. Let's check out and see where this voltage is. 8.17. Looks like we lost about 0.4 of a volt there. The type of balancing that we're using, it happens because of the direct connection between the negative and positive terminals here. And it's because, realistically, it's because it just shares the same voltage between the cells here. And I think it's really cool that this natural way of balancing here, I honestly just think it's the best. And it's probably the reason we used it at the dealership, and it was the reason I taught. I've never had a battery that's failed when I balanced a battery this way. Well, let's check and see what each individual cell voltage is. It should be consistent. It was reading 8.16 before I disassembled it here. So let's see what each cell's reading now. Each cell should read the same. Positive to positive, negative to negative. We got 8.16. 8.16 and 8.16. This way of balancing has never let me down, and I've done it with multiple battery packs over the years. So I have balancing devices, and I have a Toyota balancer, and I still balance it this way just because I know that's never let me down. Well, this concludes my tutorial video on Toyota hybrid cells. If you liked my video, or if you learned anything from my video, please like and subscribe. Thanks for watching Fully Charged Zone.